So in this video, we're going to talk about how to describe transformations of cube root functions. So the parent function of cube root functions is the cube root of x, and all other cube root functions will represent transformations of this parent function. So the transformed functions will all have the form a cube root of bx minus h plus k, where a, b, h, and k are constants that represent how the function has been transformed from the parent. So remember, there are three types of transformations. We have shifts, which are translations, stretches and compressions, and reflections. So here we have some notes on how the values of a, b, h, and k will affect the graph of the transformed function. Let's go ahead and look at some examples and see what this looks like. So we have the function f of x equals the cube root of x transformed to g of x equals 1 half cube root of x minus 4 plus 5. So I'm going to start off by highlighting the values that I see that have been changed from the original function. And then what I'm going to do is I'm going to go ahead and list these values, and I'm going to use the study guide to help me figure out how this affects the newly transformed function. So that 1 half comes in front of the cube root. Okay, so that 1 half, the absolute value of it is between 0 and 1. So that means that that is going to create a vertical compression. So now let's look at that x minus 4. So that x minus 4 is actually kind of like an x minus h, right? So if we look at our study guide, it says if we have x minus h, that's going to be a horizontal shift to the right. Okay, so we can say that this graph is going to be shifted right 4 units. Okay, and then finally we have on the end of this function, we have that plus 5. So that plus 5 is actually representing a plus k. If we go to our study guide, it says that is going to be a shift up. So that means that plus 5 is going to create a shift up 5 units. So now let's go to Desmos and let's graph the parent function and the transform function to see that we got these transformations correct. So I'm going to go to the functions menu and I'm going to get nth root and do the cube root of x for the parent. And then we're going to do 1 half. And then we're going to do the cube root of x minus 4 and then click outside the root to do the plus 5. Okay, so now we can see the original function in red and the transformed function in blue. You can see that it has been vertically compressed because this graph is flatter than the original graph. It has been shifted to the right 4 units. If we look at this turning point right here, it went from 0, 0 to 4, 5. And it also has been shifted up 5 units. So now you can go ahead and pause the video and try doing this example on your own. So here we have a graph with two transformations. First, we have that 2. That represents a vertical stretch because that's multiplying the root, and that absolute value of 2 is greater than 1. We have that minus 4 on the outside that represents a minus k, so that's going to be a vertical shift down. If we look at the graph of the original parent and the transformed function in Desmos, you can see that it has been vertically stretched because the transformed function is taller. And also notice that these points have been shifted 4 units down. So now let's look at another example where we have to write the function. So the function f of x equals the cube root of x is vertically stretched by a factor of 4, reflected over the x-axis, and shifted left 5 units to form g of x. So let's write the new function. So we have a vertical stretch by a factor of 4. Okay, so if we look at our study guide, we can see a vertical stretch means the absolute value of a is greater than 1. So this vertical stretch is going to represent a value of a. Then it says that this graph has been reflected over the x-axis. If we look at our study guide, we have reflect over the x-axis when a is less than 0. So that means that a is also going to be less than 0. And then finally, we have shifted left 5 units. So if we look at our study guide, a shift left is going to be x plus h. Okay, so that means that this is going to represent x plus h. So now let's list out all these values. So we have a, and then we have that a less than 0. So that means that that's going to be 4, but that 4 is going to be negative. X plus h means that it's going to be x plus 5 because it goes to the left 5 units. So if we write the transform function, we have g of x equals negative 4 times the cube root of x plus 5. Okay, so let's go ahead and graph this now in Desmos along with the parent so we can see the transformations are correct. So we do nth root, and so we have the cube root of x plus 5, and we need to put that negative 4 in front. You can see the graph has been reflected. It is vertically stretched. You can see this graph is taller than the original, and notice that the points are shifted to the left 5 units. So now you can go ahead and pause the video and try doing this example on your own. So here it says the cube root of x is shifted right 2 units and down 7 units. So right 2 units means we have one of those x minus h situations. And then down 7 units means we have a minus k. So when you write the equation of the transformed function, we have g of x equals the cube root of x minus 2 and then minus 7. So when we go ahead and graph that in Desmos, you can see that this graph has been shifted to the right 2 units and down 7 units. So remember, we can look at the values of a, b, h, and k to describe how a function has been transformed from the parent function. We can also use a description to go ahead and write the equation of a transformed function by adjusting the values of a, b, h, and k based on the description.